Good morning students. Welcome to a new video of cryptography. In this video, we will be dealing with the main topics like random numbers, pseudo-random numbers, the various random number generators. So let's see what is a random number first. So random numbers are the basic important criteria or the things which we use in encryption process, and it is mainly used in network security applications. For example, in Wi-Fi, for providing the security in session layer. For all these uses, we use random numbers or pseudo-random numbers. So we know we have been dealing with the encryption process, decryption process and all. So we know the importance of the secret key that is being used in the algorithm, right? So now we are learning how we are going to generate the secret key, or what are the various options or various provisions with which the secret key can be generated. So let's see what are the basic uses of random numbers in the beginning, just to go through the introduction. First use is the generation of keys for RSA. RSA is a very important algorithm which we will be studying in detail in the next video. And another use is the generation of symmetric key for temporary session keys that is being used in transport layer, Wi-Fi, email security and internet protocol security. And various other uses like Kerberos. Kerberos is a key generation technique. It's a very important technique. In this also we use random numbers. So for a number to be random, what are the basic requirements? How can we say, okay, this number is random or it satisfies the properties of randomness? So we have in detail, or we have to brief the requirements of random numbers. The basic requirements of random numbers can be comprised into two. One is the randomness, the other is the unpredictability. As the term suggests, randomness, the number which we select as the key must be random. So on what basis? There are mainly two criteria, out of which if any one is satisfied also, you can say randomness is satisfied. Let's see what are the two criteria. One is uniform distribution and the other one is independence. Uniform distribution in the sense, as we know, the keys which we be using is in the form of binary format, that is in the combination of zeros and ones. So let the key be of size 8 bits. For uniform distribution, we mean that the number of zeros and number of ones which we use in the key must be approximately same. For an 8-bit number like 44, or for a 12-bit means 66, approximately, not exactly same for in all the cases, but approximately the same. So for uniform distribution, we mean that the number of zeros and ones in the key or in the number must be approximately same. That is the case of uniform distribution. Second one is independence. A sequence from which a subsequence is derived, and there should no be another sequence from which the same sequence can be derived. That is, we have a sequence ABC, from this I derive BC. There should not exist any other sequence from which BC can be derived, which is our subsequence which is already derived. What is our aim? Ultimately, we study in cryptography the things what we should do to tighten the security. So the sequence we take or the subsequence which we derive should not be predictable, right? That's what we mean here. So independence in the sense, a subsequence which is derived from a sequence should not be derived from any other sequence in the particular key section. Clear? The second requirement is unpredictability. Of course, the members, we have a random number generator and we have generated some random number or a secret key. The hacker or the third party should not be able to predict, yeah, the next number is, or then can be maybe this one, because if he finds out the pattern which we are following is 0 1 0 1 0 1, it's easy for him. So after 3 or 2 sections he can predict, yeah, the next is also, the next term or next member is also 0 1. So in that case unpredictability fails. In short, the successive members of sequence should be unpredictable. Okay, we are selecting a number in random. You know what the term means, random. It should not be very easily predictable. Clear? So we have discussed two important requirements dealing with the random numbers. That is, one is the randomness and the other is unpredictability. Randomness, we can measure it in one or two criteria. even if one criteria is satisfied, randomness is okay. The both criteria are uniform distribution, in which the number of zeros and ones should be approximately same. The other one is independence, in which a subsequence which is derived from a sequence should not be derived from any other sequence. So it is unique, that's it. Second important requirement is unpredictability. The successive member, the next member or the next member which we suspect to be, should not be predictable. That's it. Clear? So moving on to the generators. Now we know what is a random number is and what are its uses and on what basis we say a number is random. So the basic requirements are also satisfied, right? Now we have mainly three functions or three generators using which most of the algorithms generate their random key or random numbers. Let's see. The first one is, actually three of them are like TRNG, PRNG and PRF. We'll be learning in detail. First, let's see what is a pseudo random number is. See, all the algorithms that use or that generate these random numbers are not statistically really random, but if the algorithm is really good enough, it passes the various tests of randomness. Hope you're clear. Such numbers are called as pseudo random numbers. What does the term pseudo mean? Pseudo is false. So actually they are not random, but if the algorithm is too good to prove them random, you are fine. Got it? So such numbers can be called as pseudo random numbers. First generator we are going to deal is with TRNG, is true random number generator. It's very simple. Here, as the term suggests, a true random number generator. So at the other end also you have exactly a random number, but what is differing is that in what form you get or what is the functioning that is happening in this algorithm, that you have to know. See, you have a diagram here. On the sender side or the one side you have the source, the other side you have the destination or what you call as the output. The input will be some random source. This random source can also be called as entropy source. Please note it, it's very important to know what you mean by entropy source. So I said for TRNG the input is a source, and this input source can also be called as entropy source because entropy source means that the physical environment of computer, it comprises a physical environment. What is a physical environment? The mouse clicks, the keystrokes, the disk movements, the clock, the system clocks, all these are physical environment. So all this can be considered as the input source. Clear? So this is the input source and we assume it as like, of course it is random, right? And so a source of true randomness is given as the input. It passes through the algorithm or the generator where it is converted to binary, and ultimately at the other end you have the random bit string. Okay, so the binary form is being obtained in the other end. In short, analog source to binary output is the process which is done in true random number generator. Hope it's clear. Let's now see what is PRNG. Now let's see what is PRNG. PRNG is nothing but pseudo random number generator. Now we have an idea about what is a random number, and one type of generator we have already discussed is true random number generator. Now we are going to see what pseudo random number generator does. Let's see. So here this is the diagram or figure for PRNG. Here on the input side you have a seed. Seed in the sense it's a fixed length or fixed value which is given as the input. So here the fixed input itself is called as the seed. It is fed into some certain deterministic algorithm in which the functions occur or the algorithm works or processes, and finally you get a pseudo random number bit stream. Clear? So now you have seen the figure or an arrow just like this. This is nothing but it's a feedback. That is, some results of the algorithm is again fed back to the algorithm in order to produce some certain additional output bits in case you need it. Clear? So I repeat, here the input is seed. Seed is nothing but a fixed value. Okay, that seed is fed as input to the deterministic algorithm where the input is being processed, and on the output side a pseudo random bit stream is being obtained, and some results in the algorithm itself is again fed back to the algorithm to produce some additional output bits. Clear? So this is nothing but I have just written the main points. Fixed value, seed is taken as the input, here produces a sequence of output bits using the deterministic algorithm, and this is a feedback arrow which shows some additional output bits can be produced using the results of the same algorithm. Clear? So this is pseudo random number generator. So the next type is very similar, or you can call it as a type of PRNG itself, that is PRF, pseudo random function. Pseudo random function is actually a type of PRNG itself. The main difference is that the number of bits produced at the output end differs. That is, for PRF you have a fixed length value for the output bits also, but that is not the same for PRNG. You have a pseudo random bit stream, but the length can vary, but that's not the case with PRF. For PRF, the pseudo random value will have a fixed value, that or fixed length. That is the difference between PRNG and PRF. Now let's see the diagram in detail. You have the seed as input, the same as above. Along with seed, some specific values are also fed as input. Very important. Clear? So along with seed is nothing but a fixed value. Along with this seed or fixed value, some specific value or constant values are also fed as input to the deterministic algorithm. The specific values can be some constant, can be some ID or something like that. Okay, some ID or something you can specify like that. It is fed as input to the deterministic algorithm, and at the output end or after PRF processing, we get a pseudo random value. In this case also, if you want the feedback or the results of the algorithm is fed back to obtain additional output bits, so that to fulfill the number of bits we need or that should be produced. Clear? So that is that's some most important generators we have dealt with. First we read, or we have dealt what is pseudo random numbers. As the name suggests, the numbers are actually statistically not random, but in case or if the algorithm is too strong, it passes the test of randomness. Such numbers can be termed as pseudo random numbers, and we have dealt with three important random number generators. One is a true random number, the second one is the pseudo random numbers, and the third one is the pseudo random function. That's it. Okay, now let's study in detail about the stream cipher structure. So we have an idea what is a stream cipher and what is a block cipher. In short, you can say what happens in block cipher. You give a block of elements as input or plain text, and a block of elements is obtained as the output in block cipher. But in the case of stream cipher, each bit or the block of elements is being processed continuously, and each bit is being processed at a time. So it is being processed bit by bit, or bitwise you can say, and ultimately one byte will be obtained as output at the other end. So the continuous streaming is called as stream cipher, or what is done in stream cipher, and when a block of elements is produced at the output end, you can say it as a block cipher. Now let's see what is a stream cipher structure is. This is the structure, or this is the process that happens in stream cipher, that is the encryption as well as the decryption. Let's say you have a key K, and now we are familiar with the term PRNG, that is nothing but pseudo random number generator, or any key stream generator. That's what I have written, or any key stream generator. What does it do? You have a secret key on the encryption side. Now it is being converted to some random number which makes the cryptanalyst to exploit. It makes his duty more tough. So using a random number generator, you are converting the secret key to a random number, which makes him tough or difficult to guess what is the secret key. Clear? So you have a key K. It is being given into the PRNG or some random number generator, and here the key K will be obtained in a random form. The key stream now obtained is XORed with the message, the original message that you call as the plain text. So let it be the plain text byte stream. Clear? So the plain text is now XORed with the random key stream. So while performing XOR operation, you should be very familiar with the what the function is. For XOR operation, what does it happen? For same bits, the value will be 0, and if the bits differ, the value will be 1. Clear? And it is done bitwise. Please note that it is done bitwise. So the number of bits of the key stream as well as the number of bits of the plain text must be exactly the same. Clear? So you have a key K. When it is fed into the PRNG or the random number generator, you produce a key stream which is of equal bits of that of the plain text, and that is XORed together to form the ciphertext byte stream. Clear? This ciphertext, till now what I have said is the encryption process. As we know, at the end of encryption, you get the cipher as the output. You have the plain text as the input and cipher as the output. Now what happens in the decryption side or the decryption process? The cipher is now the input, right? Now again the same key, because this is symmetric encryption, right? So the same key is being shared at the both ends. So the key K is again fed into the pseudo random number generator, where you get the key stream, the same key stream, okay? The same pseudo random sequence is being used for the decryption also. So you get a key stream which is of equal bits of that of ciphertext, and then both are XORed to get the plain text as it is, which we gave as input in the beginning. Clear? So this is the stream cipher structure. I'll explain it again. It is nothing, it's very easy. You have main two process in it, encryption and decryption. In encryption, the key K is being fed into the pseudo random number generator, where a key stream is being generated which is of equal bits of that of the plain text, because we are going to perform a XOR operation which is done bitwise, and both are XORed to get the ciphertext. Now this ciphertext is again XORed with the key stream that is being produced by the pseudo random generator, and finally you get the message back as it is. So you have the plain text byte stream which we gave it as input in the beginning. Now we have obtained it again. Okay, M denotes message, the original message or original form. Clear? So I have just noted that. Let's see. For stream cipher structure, it encrypts the plain text 1 byte at a time. Even though we say it encrypts 1 byte at a time, the operation which we perform is bitwise. Clear? So let's comprise the process. What we have written or drawn in the figure, let's comprise it. In the encryption side, you have the key as the input, okay, and it passes to PRNG to obtain the key stream, which is the output, this key. Now this key is being XORed. This output is being XORed with the plain text byte stream to get the ciphertext byte stream. So while performing XOR, make sure you do it bitwise. Clear? Yes. So these are the basic process that happens in encryption. For the decryption, the reverse. Clear? So you can see this 2 or 3 design considerations which we should keep in mind while designing a stream cipher or stream cipher structure. That's nothing but because, as we know, key plays a very important role in this, a relevant role in this whole process. So the key length should be a minimum of 128 bits. Okay, that's one important design consideration. The second one is that the key stream should be random. That is, the secret key which we give should be converted to some random form using the random generator, and make sure, because why do we make it random? So that the cryptanalyst finds it difficult to exploit our system. Clear? So these are the basic design considerations with this. Now let's work out one important example regarding this. It's very easy. Let's see. For the encryption side, you have a generator's output key stream, for example, it's given 011101100, and the input plain text which we have is 11001100. So what are these values when you compare with the diagram? The output key stream is this K, okay, not the initial key stream which we give, which is now random form, okay, that which have been passed through the random number generator. That is a key stream. So you have this key stream, you have the message, input plain text. Both are of 8 bits. Now we're going to perform this XOR function to obtain the cipher, which is the output. Let's perform XOR. Same bits indicates 0. Same, again same. It's different over here, 1 and 0. So 1, it's the same, it's different. So this is the output or the cipher text which we obtain after encryption. Now let's see what happens in the decryption. You have the cipher as the input. So I'm rewriting it again, 1010 and again 4 zeros. Okay. And what will be the key stream? As mentioned above, in decryption also the same pseudo random sequence is being used. That is, the key stream what we have here is the same as here, which means the key stream given in the question will repeat again. So let me write the key stream again, 01101100. Okay, the same key stream I have written. Now I'm going to perform again the XOR function. So that let's check if I'm getting the plain text as it is. I'm going to perform the XOR, same bits, so it's a 0, same, it's a 0, it's different, so I'm going to 1, it's different, it's 1, again a same, 0, it's same, 0, it's different, so 1, and again it's different, it's 1. Now let's cross check. Is this the plain text which I have already given? Yeah, exactly. 1100 1100 1100 1100. What does it mean? Nothing else but the decryption is also using the same pseudo random number sequence which we have been using in encryption process also. And as said in the in the stream cipher structure, the message which you have given as input and the message at last which you get at the end of decryption, both are the same, and we have verified using a example also. So this is the stream cipher structure, and hope you have a good idea about stream cipher structure. Now we are going to deal about the algorithm that helps to implement stream cipher. Let's see. Thank you.